Hey everyone, welcome to the Unit 4 review. We're talking about systems of equations and inequalities. Let's talk a little bit about what your test is going to look like. Okay, so the whole solving systems unit can be broken down basically into two sections, which can further be broken down, but you're either going to have two equations or two inequalities. All right, if you have two equations, you can solve them graphically, that was section 4.1, or you can solve them algebraically, that was section 4.2. Now, algebraically, we have substitution that we learned, and we have elimination. Okay, so that's how that works out. Now, 4.3 was actually this root of the tree when you have two inequalities, and you can only solve them graphically. So what we're going to do is we're going to review how to solve graphically, algebraically, and then our inequalities quickly. So let's start looking at the review here. This is the review that is the packet for you. We're going to start by solving by substitution. Okay, this was section 4.2. And substitution is where you get one variable all by itself. So for example number 1, I see in both equations I probably want to get this y by itself right there because it's isolated almost if you just add 3x to each side. So if we add 3x to each side, they're going to cancel, and you're going to get y equals 3x minus 2. Okay, so now you take, let's change some colors here. Let's take this y, and it's equal to 3x minus 2. We're going to plug it into the first equation right there for y. So let's write the first equation. We have negative 6x plus 2y, but I'm not going to write y. I'm going to write 3x minus 2. So that goes in parentheses. Always use parentheses when you substitute an expression in like that. Okay, and it equals negative 4. The only thing that's changed that y came out and 3x minus 2 went in parentheses. Okay, so now it's a distributive property. Negative 6x plus 6x. We have 2 times negative 2 is minus 4. All that equals negative 4. All right, so the 6x plus 6x, negative 6x plus 6x, they cancel out. We're going to get negative 4 equals negative 4. This is where we have infinitely many solutions. That's one way of saying it. Or we can call it an identity. Okay, there's no one solution to this. There are many solutions. There's infinitely many solutions, so you can say there's many answers. But that's the answer to number 1. Now, I did put it number 1 as the first one. Remember, not all systems are either identity or no solution. So just be careful. Some students like to put that after every single problem, and that's not necessary. Let's look at number 2. All right, x is already solved for. So that's obviously what we want to substitute in for. So we're going to have 2 times 12.1 minus 5y. All of that is going to subtract 6y, and it equals negative 11. All right, so we get 24.2 minus 10y minus 6y equals negative 11. And that one's set up. You can solve the rest of it. Again, this is on the review. You can check the review for all the work. Let's move on to the next part. Elimination. Elimination is where you want to look at each variable here and get them to cancel somehow. Now, in both examples, I can't get these to cancel without some multiplying. What I'm going to do in the first example is I'm going to multiply the top equation by negative 5. Now you're going to ask, why negative 5? You got to multiply everything. Negative 5 will make the x's cancel. It'll give me a negative 10x, which I need to cancel. And then the rest of it, you just got to make sure you multiply everything through. Sometimes students forget. Okay, negative 5 times 23. 5 times 20 is 100, plus another 15, so we get negative 115. All right, so we're looking at here adding the two equations together, and when you do that, the 10s will go away completely, so you get negative 15y equals, what do we get, 115 minus 76 at negative 39. This is going to be ugly. So we divide by negative 15, both sides. I know I can reduce that. 3 goes into there, 13. Well, let's put a negative 3 in. So we get 13 over 5. What is 13 over 5 if we work that out? 2.6. So y here is going to be 2.6. Then we go back, pick either equation. I'm going to pick the first one again because it's smaller numbers here. 2x plus 4y equals 23. We know that y is 2.6, so we're going to plug that in right here. So 2x plus 4 times 2.6 equals 23. All right, so we're going to get 2x. 4 times 2.6 is going to give us 8, and then we get a 0.24, so we're going to get 10.4. That equals 23. Then if you do 23 minus 10.4, that's going to give us 12 6.6. Divide by 2, 6.3. Okay? So there's the first two methods we have. We have substitution and we have elimination. In elimination, you want to get some variables to cancel. In substitution, you want to solve for one variable, plug it in the other equation. Remember, if all the variables cancel out, if they're equal to each other, it's infinitely many solutions. And if they're not equal to each other, then you write no solution. Those two are opposite, though. You can't interchange them. All right, so for 5 and 6, okay, I'm not going to solve them, but looking at them, there's a better way to solve it, and you're supposed to choose the best way. Okay, you could even graph these if you wanted to, but I wouldn't do that. Looking at number 5, the x is isolated, so I would just do substitution on this one. And the reason why is because everything is not lined up, and the x is already by itself, so just plug this expression into the other one. But you got to be careful. It's going to be negative y minus 1, all right, minus 16 equals negative 4y. I'm going to explain that again. It's negative x. Well, x is this whole quantity right here. So it's negative, and then you have that whole quantity, negative y minus 1. You then can distribute the negative. You're going to get y plus 1 minus 16 equals negative 4y. You're going to get 5y equals 15, and then you can go from there. The second, what do we got? Number 6 here, I would do elimination. And I would try to get, let's see, what can we cancel? The x's, the y's, I don't know. Let's turn the x's into 6's. That's probably the easiest. So the top equation you could do times 3, and the bottom equation times negative 2. That'll give you a positive 6x and a negative, that'll give you a positive 6x and a negative 6x. They'll cancel out. All right, enough of those. Solve by graphing. Remember, we got to get these in the form y equals mx plus b. And then we can solve it. The b is where you start. That's your y-intercept. It's called slope-intercept form. The m is your slope. And remember, you want to write that as a fraction. The number on top tells you up and down. The number on the bottom tells you left and right. You can always check yourself with a calculator, too, because we had to do that. All right, so to solve, we'll do one of these. Pick one. All right, let's go with 7. So let's solve this down here. 2x plus 3y equals negative 12. If I subtract 2x from each side, I'm going to get 3y equals negative 2x minus 12. I divide everything by 3. We get y equals negative 2/3 x minus 4. All right, that's our first equation. Let's graph that. Minus 4 is down here. We then have to go down 2 to the right 3. So that kind of goes off the page. So instead of going down and to the right, let's go up and to the left. Okay, that's just the opposite. So up 2 to the left 3, that puts us right here. Now we can draw our line. All right, so there's our line. We start at negative 4. We go up 2 to the left 3. Let's look at the other equation now. We'll do that one in red. So what are we going to do here? I would add y to both sides. That would give me this. X equals y minus 1. And then add 1 to each side. So you'll get y equals x plus 1. Okay, so you know that the slope is 1 over 1. And you know the y-intercept is 1. Okay, normally we write those things out like this. There's an m. So you go up 1, you put a point, and the slope is 1 over 1, so we're looking like right here. Up 1 over 1, up 1 over 1. So drawing that line, we are looking at maybe from here down to there. Okay, so where do they intersect? That's the question of the day. Okay, if I were to solve these algebraically, I would get a solution of x and y on the graph that appears at negative 3, negative 2. All right. There you go. There's number 7. That's how you solve graphically. You need to make sure you write your solution to the system. All right, those are the same. Just remember, I can tell automatically the slope's going to be the same for these. So if the lines are parallel, you end up with no solution. Ooh, hint. Hint. Sketch a graph of the inequalities. All right, we'll do number 12 because it has that vertical x is greater than or equal to 2 line. A lot of students have a problem with that, so let's look at what that looks like. X has to be greater than or equal to 2. All right, so the line x equals 2. What does that look like? That is a vertical line. And I always tell students, if you don't know, let's pick 2 points that have an x value of 2. So let's go with like 2, 1, and maybe 2, 4. They both have an x of 2. You're like, what's that got to do with anything? Well, let's plot them. 2, 1, 2, 4. Do you see the line that's formed? Okay, so that's the line x equals 2. But this is x is greater than or equal to 2. So We're going to have to keep a solid line because it's also equal to. Now, which side of the line is greater than? Okay, these numbers or these numbers? Well, this side is greater than 2. 3, 4, 5, those are all greater than 2. Okay, so that's the shaded part from this inequality right there. All right, second inequality, we're looking at a slope of 3 over 2, which means you're going to have to go up and to the right, and we start at -1. So down here at -1, we go up 3, 1, 2, 3, over 2. We're looking at intersection point right there. We have to be careful because this line is dotted because it's not equal to. All right, there we go. And now we need to do the shading. All right, it's less than, so we need to go underneath the line. So underneath the line is like this part. So you're going to see this part here that's double shaded, like this region. That is our solution to the system of equations. Now, in review, in brief, we're going to briefize this. Just made that word up. If you have greater than or less than, it is a dotted line. If you have greater than equal to, less than equal to, it's a solid line. If you have greater than or greater than equal to, you shade on top of the line. If it's less than or less than or equal to, you shade beneath the line. All right, I think we're good with that. Let's go to the next type of question. Okay, is the point 0, -1 a solution of this here? They're asking about 14. Let's go back and look on this one. 0, -1. It's on the dotted line, but no, remember the dotted line is not part of the solution. Only the solid line is. Okay, next part's the algebra skills. We so cool, we spell it with a Z. Did you guys check that out? We spell it with a Z. All right, so reading a function in function notation, f of 2 equals, that means you plug a 2 into it, we're looking at 0. The y-intercept, where does it cross the y-axis? Also 0. F of x equals -3. That means that the function is -3. Where's the function -3? At -1 and +3. So when x equals -1 and x equals 3. The x-intercepts, x equals 0, x equals 2. All right, so that's how you read a function notation. Simplify the radical. Remember the number line and you got the perfect squares? So the first, what is this broken down to? The first perfect square is 4 times 6. This is going to be 2 radical 6. For part B, you have that 4 hanging out in front, and then you have 9 times 6. So we have 4 times 3 times radical 6, which is 12 radical 6. All right, solving over here. I got to apologize. This worked out to a decimal. I try not to decimalize it, but you know what? It is what it is. You have to multiply everything by 42. So let's do that. So 42 times first fraction here. The 6 and the 42 cancel, leave us 7. 7 times 5x is actually 35x. And then the 42 and the 7 cancel, leaves us 6. 6 times x is 6x. And then we have 42 times 480 is 20,160. So now when I put these together, what do we get? 41x equals 20,160. When I divide by 41, I'm going to get like 491. Is that right? Did I do that right? 491? We're going to get 491.7. That is crazy. Hey, but it is what it is. All right, part B. It's A times C. There's a 1 there. So A times C goes in the top. You get -45, a -4 in the bottom. So you're talking about 9 and 5. -9, +5. So we're going to write the answer to this is x minus 9 times x plus 5. Those are the algebra skills for us. Is that it? That is it? Now we have the application problem. Now, Bruss loves creating sculptures with candles. All right, so he's going to buy some candles. We have small candles, X, and large candles, Y. What I want to do is walk you through this problem, and that's why these different parts are here. So it just doesn't say, like, graph the inequality. It's walking you through for a reason. All right, so we need to write an inequality for each of the following components. First one, Bruss wants to buy at least 20 candles. Okay, he's going to buy small candles, X, plus large candles, Y. So X plus Y has to be greater than or equal to 20. All right, eventually we're going to solve that for Y, but not yet. Next part, Bruss cannot spend more than $200. So how much does he spend in small candles? It's the number of small candles times however much they cost. So that's 4 times X, $4 times the number of small candles. Same thing for large, $5, so it's 5 times Y. and that has to be less than or equal to 200. All right, so you solve each one of these for y, or you could do it. You could graph it by using the intercepts, but I just solved it for y and I graphed it. Okay, this is the solution I get. I get the number of small candles here, the number of large candles there. Okay, it's y equals mx plus b. It's the normal thing that you already know how to do. The y, though, is the number of large candles. Okay, and x is the number of small candles. Name one point that is a solution. Okay, you just go inside the shaded region. I came up with 15 what? Small candles, 10 large candles, and one point that is not. Okay, so let's go to the very last one. Fear factor. The life of a young boy who factors trinomials while feeding alligators. That's clever, huh? So on the first day, Bean sold 3. Now I can almost see this equation coming out of my head right here. 3 senior citizen tickets. So it's 3x, okay, plus 15 child, 15y. That equaled $171. On the next day, it was 3 senior citizen, 8 child is $111.50. Okay, you have those two equations. I would use elimination, multiply the second one by -1, solve it, you get y equals 850, and so on and so forth. You should be good to go. All right, so that is our algebra review. Uh-oh, that's not where I'm going, right here. That is our review for Algebra 3. I guess I don't have anything else to say. People, good luck on that test. This is Mr. Kelly Baumholder. Remember, it's nice to be important. It's more important to be nice.